Friends, in this video we are detailedly study about the steel rolling mills. So let's begin. The steel rolling mills. But before we're going to start the steel rolling mill, actually we want to understand what do you mean by the process of the rolling. So friends, as we seen that uh, different types of industry, that will be the manufacturing industry, the rolling is one of the important processes in the modern world, because if you want to convert any type of the finishing product from the any type of metal, the first process that we want to move, and that the process will be called it as the metal rolling. So friends, as we seen that this is the figure of the metal rolling process. So as shown in figure, friends, we are seeing this is the workpiece by which we have to convert a different types of sheets, different types of bends, or different types of structures. So friends, this is a workpiece. So for that particular workpiece, the direction of the workflow will be from that the left hand side to the right hand side, and we are using the different two types of rolls. So this is the first roll and this is the roll number second. As we seen that, friend, the direction of these rolls are opposite to each other. So for the direction of this particular roll, the workpiece which will be available in between that particular two rolls, that will be converted into the different types of the thin sheet. Now this thin sheet, according to our requirement, we are moving towards that the thin sheet into a required form. So this is the actual process of rolling. Now friends, we have to understand what is the raw material that we are using for the rolling process. So first of all, we can understand, friend, ingot or the continuous casting is a hot rolled into a bloom or a slab. So later on we can understand what do you mean by the blooms, what do you mean by the slabs, what are the different types of bloom mills, what are the different types of the slab mills. So obviously we have to understand this process first of all. So friends, as shown in that particular figure, if you want to understand the steel rolling mill, so obviously the steel ingot is the cast metal with porosity and blow holes. Ingot is the soaked at the hot rolling at the temperature near about 1200 degrees Celsius, and then rolled into blooms or billets or the slabs. So as shown in figure, friends, if you want to understand the detailed process of the steel rolling mill, we have to get one type of the ingot. And what do you mean by the ingot? It is a simple a continuous casting of that particular metal piece, and we have to roll that particular casting material by the means of the different types of blooms or slabs, and by which we can get a finished product of the steel sheets or steel bends or the steel type of the structure. So this is the actual process that we are carried out in the different types of steel rolling mill. Now friends, we can understand the detailed concept of what are the different two types of mills that we are using in the different types of steel rolling mill. So friends, in the steel rolling mill, we are using the different two types of mills. First type of mill will be called it as the blooming mill, and the second type of mill that we call it as the slabbing mill. So first of all, we can understand what do you mean by the blooms. So the blooming mills, the blooms are typically have a square cross section of greater than 6 by 6 inches or 6 into 6 inches. Blooms are typically have a square cross section of greater than 6 into 6 inches. So this is called it as a bloom mills. And what do you mean by the slabbing mill? Slabs are rectangular and are usually greater than the 10 inches in the width and more than 1.5 inches in the thickness. So depending upon our requirement, whether we are using the blooming mills or whether we are using the slabbing mill for a particular type of the steel rolling mills. So basically the rolling is most often, basically particularly, or we call it as rolling is most often, particularly in the case of the conversion of the ingot or a continuous casting, preferred very hot. So friends, we are using the different types of rolling that will be called it as a hot rolling for your steel type of industry. So friends, now we have to understand what are the different the processes that we are carried out while we are using the different types of the material that we are getting from the steel industry. So the first raw material that will be called it as ingot. So from the ingot we are getting the different type of processes. So that the processes, as we have seen, there are the different two types of mill. So first type of mill will be your blooming mill. So we have already discussed what do you mean by the blooming, what is the shape, and the second type of that will be called it as the slabbing. Okay, so friends, as we seen that depending upon the different type of structure that we are getting from the steel rolling type of the industry, we have to use the different types of blooming mills. So as we seen that this is the first part of the blooming mill by which we can convert that the blooms into the section of the billet, and from that billet we have to convert the different type of the structure of the bar, because as we seen that the different types of the civil work, different types of the industry will prefer, some industry will prefer the circular type of bars, some industry will be prefer the rectangular type of the bars. So depending upon that particular requirement, we have to convert starting from the ingot to the steel bar. We have to follow this procedure. So what is the procedure? From the ingot we have to convert, that is from the bloom mills. From bloom mills we have to convert, that is from the billet, and from billet we have to convert according to our shape requirement. Sometimes it will be a circular, sometimes it will be rectangular, or sometimes we have to convert, that is a triangular shape of the steel type of the product. So this is one of the process that we are carried out in the different type of the steel industry. In the second process, again we have to get the raw material from the steel industry, that is called it as the ingot, and from that we are using the different types of blooming mills. So in that particular blooming mills, the raw material now it will be converted as in billet. So from that particular billet, now we have to convert according to our shape requirement. Suppose friends, you have to require this type of shape for your steel rolling mill. So from that particular billets, we have to convert the different types of shape. So according to our requirement, we have to convert the different types of shape from the steel rolling mill. So this is another process. And the friends, the next process for the steel rolling mill, which will be called it as the slabbing. So most of the time while we are producing the different types of sheets that we are using for the different type of industry for the enclosure purposes, then we are using the process instead of the blooming, we are using the slabbing processes. So what do we mean by the slabbing? So in that particular slab we have to convert raw material, that will be called it as the ingot, to the slabs, and now that slabs will be converted according to our requirement. Suppose we have to get the requirement of the steel industry in terms of the plates, so we will convert that the ingot. From slabbing process we have to convert these steel sheets into a different types of plates. We have to convert the different types of strips from that particular steel industry. Now we are using this type of sheets or strip from your slabbing process. So friends, this is the actual flow of the processes from that particular the steel rolling mill. And now we have got the fundamental concept in concern with what will be the basic part of your steel rolling mill, what is the raw material, and from which we can get the different types of finished products. So these finished products that we are getting from the different type of steel industry, some products will be called it as bar, that is the rectangular, triangular, circular, or we have to get according to our requirement the different types of shapes. These shapes will be look like that, some of the shapes will be look like that, and we have to get the different types of steel plates, different types of steel sheets, and steel strip. Now friends, we will understand the detailed actual manufacturing process of your steel rolling mill. So friend, this is the actual flow chart of your steel rolling mill. So friend, this will be the first step that we are using in the steel rolling mill. This is the second step, this is the third step, this is the fourth step, this is the fifth step, and after that particular fifth step we are producing the last step of the manufacturing process. So first of all we can understand what do you mean by the first step in the steel rolling mill. So in that particular steel rolling mills, the slabs are heated in the slab furnace, get a correct rolling temperature of about 1 to 50 degrees Celsius. So friends, this is the first step by which we can just slabs are heated at the particular temperature of 1250 degrees Celsius, by which we can convert the metal slabs or metal ingot into a hot rolling mill. Now we are using the different types of the roughing mills. So by the use of that second after that particular process, now we are using the different types of roughing mill, that the slabs thickness of 220 mm is reduced to the 30 mm, because while we are sending this objective from the first step to the second step, the temperature of that particular object will be very large, so it is near about 1 to 50 degrees Celsius. So now the thickness of this sheet will be larger, that is a 220 mm. By this process of the roughing mill, that we are converting the shape or the thickness of that particular sheet into the 30 mm. So then the steel is cooled and increases in the length from its meters to a coil with a 80 meters at a heavy weight. So from this process we are getting the different types of plates. Okay, so from that particular plates, friend, we are moving towards the next type of process. Then this type of process will be very simple. So this is the process of the cleaning. So we are getting the different types of plates from that particular processes of the smaller thickness. Now we have to clean that particular sheets because some of the different types of the moisture contain different types of the particles that we are inserting on that particular sheet. So we have to clean that particular particles. So this is stage by which we can get the cleaning of that particular object by use of the milliscale in the several stages of the different types of the cooling of the system. Okay, so friends, now we are going towards the very important type of the process that will be called it as the hot rolling. So friends, in that particular hot rolling that we had already discussed, what do you mean by the rolling process in the industry, because we have to get, this is the actual product by which we have to convert the product into the different types of the shape of the sheets. So this is the process by which we call it as the hot rolling process. So what is happening in that particular in a hot rolling process? So obviously in this particular process, a wide strip metal that can roll the whole width of the slab in one passes through the six stands. So extreme forces are applied to the rolls, and that rolls are steel to the thickness of between 16 mm and 1.8 mm. The rolling speed is 120 km per hour at the end of the hot rolling mill. If the sheet is rolled down to the thickness of 2 mm, the sheet will have grown in the length from 80 meters to the 1300 meters. So friend, this is very important process in the steel rolling mill that we call it as hot rolling. So simple, we can change sheets that we are getting from that particular the raw material. Now we have to convert at the length of the sheet, that is from, because we are getting the length of sheet from the stage number 3, that is the 80 meter. Now by the process of this hot rolling we are getting these sheets up to the 1300 meter, because we have to place the different types of rolls in that particular hot rolling mill. So friends, this is the step number 4. After the step number 4, we are moving towards the step number 5. What do you mean by the step number 5? So in that particular step number 5, we have to cool that particular sheet. Why we are cooling that particular sheets? Because we have to strengthen its strength, that is tensile strength or its mechanical strength. So that's why we have to cool at the particular sheet before we are converting into a finished product. So basically the cooling will be done by the temperature of the 600 degrees Celsius. So this will be the process number 5, and after the process number 5 we are getting the finished product. That will be, we are converting the different types of the steel sheets, steel according to our requirement. So this is the circular type of steel sheet, this is a rectangular type of steel sheet. So this is hot rolled sheet. Steel is solid in coils or cut to the length. So this is the manufacturing process of the steel rolling mill. So I think we have understood the detailed understanding of the steel rolling mill. Now we have to convert what is the different types of, so this is the actual process that we had already discussed earlier. So most of the industry we are using the different types of the bloom mills. Sometimes we are using the two roll system, sometimes we are using the three roll system. For the sake of that particular industry of the steel rolling mill, what is the requirement? Because while we are understanding the detailed manufacturing process, so what is the requirement for that particular industry? We will require the motors which will be having the heavy torque and low speed of rpm, and we have to effect a very heavy type of reduction of the material from the ingots to the blooms or slabs. So this is the requirement for the different types of steel rolling mill. So we have to use the two blooming mills, that is the two rolls blooming mills, or we are using the three rolls blooming mills. So what do we mean by the two rolls blooming mill? So we have to use two rolls, and in between that particular the two rolls we have to use the object. So friends, this is the two rolling bloom mill, and in case of the three rolls blooming mill we have to change the rotation will not be changed because in the two rolling mill we have to change the rotation, but in concern with the three rolls blooming mill, we don't have the priority to the change direction because we have to move the material between the lower and middle rolls, so between middle and top rolls. So obviously we cannot change the direction. So most of the time in the industry we are preferring some of the two rolls, some of the three rolls, so depending upon the requirement of your system. So from that particular blooms or the slabs we are getting the different types of finished product that we had already discussed. We are getting the different types of plates, structural bars or billets, or we are getting the round shape, square shape, or flats angle, different types of materials. Sometimes we are producing the different types of the square octagons type of the structure. So these are the different byproduct that we are getting from the different type of the steel rolling mills. So friends, now we can understand which type of drive that we are preferred. So this is one of the block diagram by which we can understand the PLC control, that is a programmable logical control system by which we can control the different types of drives. So as we seen that the motors or the different types of drives that we are required for the different type of the steel rolling mill. So as we seen that the main process that will be carried out, that will be called it as the main stand, and for the driving of that particular main stand we are using the main stand drive. So what is the requirement? So the requirement for the main stand drive will be called it as the high torque and low speed applications. So as we seen that the motors that will be preferred for, which we prefer very high starting torque and low speed, so that the motor will be discussed later on. So as we seen that in the different types of electrical industry, the only motor which will be provide that will be very high starting torque at the low speed with the different types of the supply system. So that will be the three-phase slip ring induction motor. So obviously for the sake of the main stand drive we are preferring this type of the drive system, which will be called it as a three-phase slip ring induction motor. Okay. Then there are the different types of drive which will be called it as a cooler drive. So for the sake of that particular cooler drive, sometimes we are preferring the different types of the constant speed motor because we have to cool that particular object. So friends, for the sake of that particular cooler drive we have to prefer the different types of drives that will be called it as a synchronous motor drive. Because what is the purpose of that particular drive? Because we have to control the processes at a constant speed. So for the sake of that we have preferred different types of the synchronous motor drive for that particular application. So friends, this is the actual layout of your steel rolling plant. Now we can understand in detail what are the different conditions in a steel rolling mill while we are selecting a different types of motors or drives for a particular purpose. So the first type of the requirement or the first type of the condition is that while we are selecting this motor as a drive for a steel rolling mill, so the first requirement is that the motor should have a robust construction, withstand severest duty. Because as we seen that in the steel rolling mill the temperature of that particular steel rolling mill will be very high. So for the sake of that, while we are selecting a motor, that the motor should be a robust construction, and obviously there should be a different types of duty cycles are there. So in that steel rolling mill we have to select a motor which will be having a severest duty. So this is the first requirement. And the second requirement for the steel rolling mill will be that so it should be capable of the developing short time torque to the extent of 2 or 3 times of the rated torque. So the second requirement very important. So this is the drive while we are selecting for the steel rolling mill, that the drive should having very high starting torque. Then the third requirement of the steel rolling mills motor, so it should be capable of having a wide speed variation, because according to the different types of the sheet metal, different types of the structure, so the motor which will be having a wide speed variation. So this is the third requirement. And after the third requirement, now we are moving towards a fourth requirement. So what do you mean by the fourth requirement? So it is very important. So the motor should be in the position to maintain a selected speed within the tolerance from no load to full load. Therefore, it should have a quick response to the change. So obviously, while we are selecting a motor for the steel rolling mill, so this motor will be changes its speed from the no load speed to the full load speed, and the quick response is very important while we are selecting a motor for a this process. So now we can understand which type of motors that we are prefer for the different types of the steel rolling mill. So obviously friends, according to our different type of requirement, we have to use the different types of motors for the steel rolling mill. So now we can discuss which type of motor which will be applicable for which type of the applications in the steel rolling mill. So obviously the first important motor that we will use for the steel rolling mill, that will be called it as the slip ring induction motor. So why we are using the slip ring induction motor? Because we have to convey the different types of the operations, because as we seen that in the hot rolling process we have to convert the starting torque that will be greater than basically the 2 to 3 times the rated torque. So the construction of that particular motor will be robust. So obviously we are preferring the slip ring type of the induction motor for this purpose. Now the second type of motor will be called it as a DC motor, because we have to start the different types of the conveyor belt, different types of the processes by which we can get the constant speed of your, because we have to convey the different types of the steel metals on the different types of conveyors, different types of belt systems. So for the sake of the driving of that particular system, we have to prefer the different types of DC motor. So friends, as we seen that in the case of the previous industry, so the industry that will be preferred, that is before 1980, we are preferring the different types of DC motor for the different types of purposes in the rolling mill itself. After that we are using the different types of synchronous motor. So why we are using the synchronous motor? Because synchronous motor will be having constant speed application, and for the cooling purposes we will require some of the synchronous motor. So for the sake of that, in the different types of the rolling mills we are preferring the synchronous motor. Now friends, nowadays in a steel rolling mill, most of the time we are preferred the BLDC motor, because this BLDC motor is the latest development in the DC motor. So obviously the BLDC motor will be most of the preference while we are using the different type of the positioning system, quick response, all the advantages which should be available in the BLDC time. So nowadays in the industry we are preferring most of the BLDC motor for the rolling mill instead of your DC motor. So these are the different motors. Later on we will discuss in detail which type of drive that we are prefer for this type of the motor. So friends, we can start the first type of the motor, that will be called it as the slip ring induction motor. So friends, as we have basic understanding of the slip ring induction motor, because according to the construction of the slip ring induction motor, so we have the basic parameter thing. So in that particular slip ring induction motor, we have, this is the stator of that particular your slip ring induction motor, and we are applying the voltage supply. So we have the voltage supply, this is the phase R, this is phi, phase Y, this is phase R, this is phase Y, this is phase B. So we are applying, so we are using the R phase to that the particular first phase, this is Y phase to your second system, this is the third phase, and this is the stator of your three-phase slip ring induction motor. So we are applying the voltage supply to that particular stator of your slip ring induction motor. This is the stator circuit, and this is the rotor circuit. So in the rotor circuit itself we are using the different types of resistance. So why we are using this resistance in the different types of the rotor circuit? So this is the rotor circuit of your system. So this is the rotor circuit, and this is the variable resistance. So this is the stator circuit, this is the rotor circuit of your slip ring induction motor. So in that particular rotor circuit of your slip ring induction motor, we are connecting the different type of resistance. So this is the rotor resistance control of your slip ring induction motor. By the changing of this particular rotor resistance value, we can change the speed of that particular slip ring induction motor. So this is one of the useful method of the controlling of the slip ring induction motor. This method will be called it as a rotor resistance control. So friends, while we are using a slip ring induction motor in the different types of the rolling mills, so why we are using the slip ring induction motors? So it is suitable for the roughing stands of the rolling mill. So for the sake of that, we are using speed control method of your slip ring induction motor, that will be called it as a rotor resistance control. So friends, there are the different disadvantages of the rotor resistance speed control technique. So for the sake of the slip ring induction motor, most of the time we are preferred instead of that speed control method, different types of speed control method, that the speed control method will be called it as a slip power recovery scheme. So in that particular we have to recover that the value of the slip power recovery. So most of the time in the industry we are preferring this type of the slip power recovery, but for the sake of the slip power recovery the cost is very large. So that's why for the sake of the steel rolling mill, now though the disadvantage of the slip ring induction motor is that is the wastage of energy. So this is the wastage of energy disadvantage. Along with that, we are prefer this motor for the steel rolling mill. So what do you mean by the wastage of energy? So this is the wastage of energy in the rotor of the slip motor, which is proportional to the reduction of speed, can be avoided by employing a cascaded induction motor. So this is called it as the slip power recovery induction motor scheme that we will use nowadays in the industry. So besides the wastage of the energy taking place into the rotor, introduction of the resistance in the rotor circuits converts speed torque characteristics of the induction motor. So friends, instead of that wastage of the energy, though the slip ring induction motor are preferred for the different types of the processes that will be called it as a roughing stands of the rolling mill in the steel rolling mill. Now we have to understand the drives understanding of the detailed rotor resistance slip ring induction motor. So friends, this is actually the closed loop speed control scheme, or we call it as one type of drive that we are preferred for the controlling of the speed of your slip ring induction motor. So as we seen that this is the three-phase supply which will be available, that is RYB. This is the slip ring induction motor actually. So this is the part will be called it as the stator. This will be a part will be call it as a rotor. So as we seen that from the rotor circuit we are connecting a resistance. So what do you mean by the resistance? So in the rotor resistance drive we are using the different types of the converters, that is will be called it as a different types of the power electronic devices. So as we seen that from that particular rotor circuit, so this is from the rotor circuit we are converting diode bridge rectifier. So what is the purpose of this diode bridge rectifier? So this will be having the AC supply. So this the AC supply will be converted into DC supply by means of this particular diode bridge rectifier. Now this DC supply will be not pure DC, so this will be having some of the pulses, that is a pulsating DC. So this ELD will be called it as a inductance, so by which we can get purely DC supply. So now we are using resistance which will be across your rotor resistance circuit. So obviously friends, we are getting this value of the resistance, and now friends we have to change the value of this resistance by the use of the different power electronic device. So friends, as we seen that this is one type of the transistor which will be having the terminal, that is emitter, this is base and collector. So this is the power electronic devices which will be changing the value of the resistance. While we are changing the value of the resistance by means of these transistor devices, the speed of that particular induction motor will be changes, and this is the speed control strategy that we are preferring for the steel rolling mill. So friends, as we seen that this is the base terminal of your transistor, and we have to change the basically duty cycle of that particular transistor, so by which we can change the speed of that particular slip ring induction motor. So friends, this is the actual closed loop control scheme. So now we can understand what do we mean by this particular closed loop control scheme of your rotor resistance control. So this is the motor. So as we seen that the fundamental block diagram of the closed loop control scheme, we have to sense the speed of that particular motor. So now we can sense the speed of that particular motor by the using of the speed sensor. Now we have to give this the value of the speed to your summing point. So this is the speed of your motor, and we have to control the speed of motor. Suppose we are taking the example, now the speed of this induction motor 1500 rpm. So friends, now we have to control the speed of that particular induction motor, that is 1400. So our requirement is that we have to control the speed of that particular induction motor is to 1400. So the reference speed now it is 1500. So this the summing point will be basically converting the error signal, that will be 100 rpm, and now this error signal will be given to your speed controller. Now this speed controller will control the value of that particular speed, and it will be generate signals according to the different types of 100 rpm. So now these 100 rpm signals which will be converted to the different types of current signal, because as we know that in the speed control loop we have to use the current limit control loop. So this the 100 rpm signal will be converted into in terms of the current. Suppose the current of this system will be 5 ampere, and now we have to control the speed of that particular 5 ampere to the, so what is a requirement? We have to control the speed of that particular drive, that is from the 1500 rpm to the 1400. So we have to control the speed of that the particular motor by the use of the CLC loop. So we have to limit the current loop, that will be 5 ampere to the current loop, that is a 4 ampere. So it is current limiter that will be limit the value of the current from the 5 ampere to the 4 ampere. And now this the current of this value, that is will be the called it as a 4 ampere, that will be given to that particular system. So we have to get the current of this particular system by means of this point. So this the current of the system will be 5 ampere. So this is 5 ampere, this is 4 ampere. So this is summing point. Again, it will generate the error signal of the 1 ampere, and now this 1 ampere will be given to your current controller. So in the current controller, we have to control the signal according to the 1 ampere, and now we have to use the different types of drives. So we are using the different types of the base drive by which we can convert that the 1 ampere signal into according to its duty cycle. So it is T on period, the total time period T. So according to that, we have to give the signal to that particular transistor, and now this transistor according to its duty cycle, it will change its value of the resistance. If the value of the resistance will change, obviously the speed of that particular slip ring induction motor will be changed. So this is the one type of drive preferred in the slip ring induction motor. So friends, in this way we have detailedly study about the slip ring induction motors drive. So friends, nowadays in industry, instead of this particular the slip ring induction motor, most of the time we are preferring variable frequency drive as well. So I think we have the basic fundamental concept that we are getting from the variable frequency drive. So some of the time of the industry we are preferring VFD as well. Now friends, we are moving towards the next type of motor that we are using for the industry, that will be called it as the steel rolling mill, that will be prefer for your steel rolling mill DC motor. So what do you mean by the DC motor? So the DC motor will be very popular or for the steel rolling mill because of its inherent characteristics, because as we know that the DC motor will be giving a better speed regulation, so the speed regulation will be very large. So that's why the DC motor are the suited for the rolling mill operation. As we know that the DC motor will be possesses the different types of properties. Such a property will be called it as constant torque at the rated speed operation or the constant torque at the low speed application. So as we know that the different types of the speed control strategy that we are preferring for the DC motor. So the DC motor speed control strategy, first of all, which will be discussed, that will be called it as by the changing of its armature voltage and by the keeping the field constant, by which we can get constant torque operation at a rated speed. So this is very important characteristics that we are getting for the first speed control technique, that will be called it as armature voltage control. And obviously from the DC motor we are getting the different type of the property, that is a low torque and high speed applications. So in most of the rolling mill, along with high starting low speed application, sometime we will require that is low torque and high speed applications. So obviously where it will be required, so in the rolling mill the final passes when the section of the stock having become smaller, torque needed is low, and the elongated material requires very high speed to clear off in the shortest possible time. For the sake of that, we are using by the weakening of field, means obviously we have to control the field flux control. So after that the rated speed is achieved by the increase of the applied voltage to the armature. So friends, in this way we have to get low torque and higher speed applications in the different types of the steel industry. So in the different type of steel industry we will require this type of the requirement. So what is the requirement when the stock will be having a smaller and elongated material, which will be required very speed. Okay, so for the sake of that we are preferring the DC motor in the different type of the steel industry. Obviously in the steel rolling mill we have to use the different types of reversible rolling mill. For the sake of the reversible rolling mill, so the DC motor will possesses the different reversing operation by the use of the different types of the speed control mechanism, because the DC motor will possesses one type of speed control mechanism that will be called it as Ward-Leonard speed control strategy, by which we can get the speed control of the DC motor that is below the base speed as well as above the base speed. So for the sake of the reversible type of the rolling mill, we are prefer the DC motor drive for this operation. Now we can understand what are the different types of the power modulators or the different types of the drive system that we are preferring for the different types of the DC motor which will be available for the rolling mill. So friends, as we seen that DC motors of rolling mills can be supplied from any of the following method. So the methods, first method will be, that is grid controlled Mercury arc rectifier. So friends, before the eras of the 1970, this type of the drives or this type of the supply system that we are preferring to operate a DC motor in a steel rolling mill. But nowadays, the grid controlled Mercury arc rectifier are totally replaced by the system of the SCR control rectifier, because nowadays we are using this type of the supply system. So nowadays we are using the SCR control rectifier system, and we have to use for the reversible type of drive, we have to use the Ward Leonard set. So Ward Leonard set will be preferred for the speed control, that is below the base speed and above the base speed in the steel rolling mill. Speed control below base speed and above the base speed. So these are the different methods by which we can get a DC supply to that particular DC motor. Now we have to use the first method, that will be called it as grid controlled Mercury arc rectifier. So this is very absolute method. So before 1970, this was very popular method which will be used for your steel rolling mill. So what do you mean by the grid controlled Mercury arc rectifier? So as we seen that the name itself indicates its meaning. So we can discuss. So the first part will be called it as rectifier. So rectification process, we have to convert the alternating current supply into a DC supply. What do we mean by the arc? So in the basic electrical engineering, we have the concept that is arc is the current flowing through that the insulation media, and we have to use a mercury type of the material for the production of this particular arc. So grid control. So basically grid control means we have to control this the mercury arc rectifier by means of the gridding. So that's why this whole system will be called it as grid controlled mercury arc rectifier. So friend, this is the diagram of the grid controlled mercury arc rectifier. So we have to understand what are the different parts. So very important part for the grid control mercury arc rectifier, we have to require two types of devices. First type is anode and cathode, and in between that anode and cathode we have to generate one type of arc. And as we know that what do we mean by arc, the current flowing through the insulation media. So friends, as shown in figure, this will be the anode, this will be the anode lead, this will be the cathode. So we have to use as a cathode material, this material will be called it as mercury. So the form of this cathode material is not a solid, it is a liquid mercury. We have to use the material for the cathode, it is mercury, and for the material for the anode, we are using the graphite. That is a graphite material which will be used for this anode material. Okay. So friends, this will be basically arm. This is the arm. This is the excitation electrode by which we have to give the excitation, or we call it as the supply electrode. This is basically ignition anode. So this, what do you mean by the ignition anode? Again, the purpose of this ignition anode is to ignite whole system, and these are the cathode leads. Okay, and friends, very important, we have to use one tube that will be called it as a gas tube, and basically it will be a vacuum because it is a totally enveloped type. So what do you mean by the gas enveloped? So this is one type of the vacuum tube made up with the glass, by which we can produce a different type of arc. So friends, now we have to understand what will be the working. So friends, while we are giving the supply to the excitation electrode and the ignition electrode, so by the use of that particular ignition electrode, is all system will be a vacuum system. So it is available, that is inside the gas envelope. So as we know that according to the basic electricity principle, while we are ignite some type of the anode, while we are giving the alternating current supply to that the type of the different types of the anode circuit. So as we seen that the electrons are liberated from the different types of device. Okay, so basically this is the cathode type of the liquid type of the mercury. So this is the liquid type of mercury will liberate a different electrons. So this cathode will be liberated most of the type of the electrons from that particular surfaces. Similarly, the anode will generate or liberate some of the electrons. As we know that friends, in the basic electricity, when the current flowing through the circuit will be going when the direction of the flow of electrons. So the direction of the regular current, and the direction of electron is basically opposite, because these the electrons which will be generated from that particular supply of the cathode. So we are giving the positive supply to that anode, negative that is, so we are giving the supply. So this cathode type of material will liberate maximum number of electrons, and these electrons are now moved towards the anode, because as we know that the anode will having a positive polarity, cathode will having a negative polarity. So these negative electrons are attracted towards the anode. So if these electrons are attracted towards the anode, so the conduction path is complete, and obviously when the electrons are attracted towards the anode, a current will be flowing through that the anode to cathode. So this current will be called it as arc. So due to that, one arc will be produced in that particular the gas envelope. So due to that, some of the light will be generated, because as we know that what do we mean by the arc. So the current flowing through that particular insulation media. So this current will be flowing through that the anode to cathode, and as we know that this direction of this current will be a unique direction. So we are getting the DC current from that particular mercury arc rectifier. Before 1970, it was very popular method to generate the DC voltage. So what are the different advantages of the grid control rectifier? So basically this grid control rectifier will provide you the overload capacity and steplets control voltage from 0 to 100%. So we have to control the voltage that is from the 0 to 100%. Then the efficiency of this type of the rectifier will be large. So the efficiency of this rectifier is very large, and this rectifier will be used for the quick response to very rapid change in the operating variable, because this is a requirement in the different types of the rolling mill. The only disadvantage of this particular mercury arc rectifier is that the load peaks causes by the operating of the mill are transferred to the feeding system. So due to that, one of the disadvantages of the mercury arc rectifier, due to that particular reason, mercury arc rectifier, which is works only as a wall, is recommended for the supplying the rolling mill where AC supply network is sufficient strong. So due to that, friends, this mercury arc rectifier will be very popular before the era of the 1970. After that, friends, we are moving towards the next type of the rectifier, because after 1970 there is basically rise in the rectifier system, because there are the different disadvantages of the mercury arc rectifier that will be recovered by a very popular device. This popular device will be called it as silicon control rectifier. So nowadays we are prefer this type of the rectifier, which will be called it as SCR controlled, that is silicon controlled rectifier. So the main advantage of the silicon controlled rectifier, so these are available in the smaller size, because while we are using the grid controlled mercury arc rectifier, the size of this particular mercury rectifier will be very large. So the size of this silicon control rectifier will be very small. So that's why most of the type in the after the 1970 we are prefer this type of the rectifier circuit, which will be called it as the silicon control rectifier. So due to that particular reason, the silicon control rectifier, which works only as a wall, is recommended for the supplying of the rolling mill where the AC supply network is sufficiently strong, because we have to control that the AC supply converting to the DC supply, so that device will be treated as a rectifier. So this is a SCR. So what do you mean by the SCR? So SCR is nothing but a very simple type of the devices which will be having one terminal, which will be anode, second terminal will be the cathode, and the third terminal which will be having the controlling terminal, that is called it as gate. By the changing of the gate terminal voltage, we can control the control signal of this particular rectifier. So this is called it as silicon control rectifier. So silicon control rectifier is basically made up of three layer system, that is the material that is PN. This is gate terminal. Okay, so this is, we call it as anode, this is, we call it as cathode. Okay, so and this is a gate terminal, so by which we can get a different type of junction J1, J2 and J3. So at the time of the operation, the junction that is J1 and J2 will be called it as in forwarding, this is in reverse bias. So obviously in the second operation, that will why we are using, that is a forward blocking mode, reverse blocking mode. This junction that is J1 and J2 will be in reverse blocking, J3 in the forward blocking, so due to that there is no flow of current, but while we are giving the positive signal to that particular gate terminal, so the current flowing to that the particular device, and by which we can get the control signal, and we can convert, that is the alternating current supply into a direct current supply. So I think we have the basic fundamental understanding of this SCR. So that's why in the industry we are prefer the silicon control rectifier for the use of your DC motor. So friends, along with that we have a simple fundamental diagram in concern with the silicon control rectifier fed DC drive. So I have to draw this diagram by erasing of this particular term. So now we can erase this term, and we can discuss SCR controlled DC system, or SCR controlled DC motor. So we have the basic fundamental concept of the SCR controlled DC motor. So friends, now we can understand what is the concept. So we are having the alternating supply. This is the SCR circuit. This is the SCR circuit. We are using full wave controlled rectifier, and from which we are getting the, so this is the AC supply, that is current. These are called it as the different types of the SCRs that we are using. Okay, so this is the current IA, from which we can generate voltage, or we can just connect one motor, that will be called it as the motor. So this is the armature circuit. Suppose it is a separately excited motor, so it is a field circuit. So the current flowing, that is IF. So this is field voltage, that is F1 F2. This is A1 A2 armature circuit. So friends, while we are using, most of the time this whole circuit will be represented by this simple fundamental of your circuit. So this is understanding, that is basic circuit element R, this is L, this is C. Okay, so by the use of this RLC, we have to control by the changing of this firing angle of this particular SCR, we have to change the speed of that particular DC motor. So this is called it as silicon control rectifier. So this is R terminal, this is L terminal, this is E terminal, because this is a separately excitation terminal. Okay, so this is silicon control rectifier. Now we have to understand the next concept of the DC drives control, and that the concept will be called it as the Ward-Leonard control. So I think we have understood the detailed concept of the Ward-Leonard system, because the main advantage of this system will be that, so load peaks is not transferred to the supply. So by the means of this particular system, the load peaks are not transferred to the supply. So that's why we are preferred this Ward-Leonard set system for the use of the steel rolling mill. So we have the basic fundamental concept, because this Ward-Leonard speed control system will prefer for the system that is below the base speed and as well as the above the base speed. So we are having the three-phase supply that we are giving to the AC motor, because for the sake of the Ward-Leonard system we will require AC motor along with a DC generator. So as seen in that particular diagram, we are applying the AC supply to that particular motor, which will be called it as the AC motor. Okay, so friends, the AC motor is coupled to your generator, so we have to get the speed control below the base speed. So by the changing of the armature voltage of that particular generator, this generator and motor are coupled to each other. While we are changing the voltage of this particular generator, we have to change the armature voltage of this motor. So we have to get the speed control of this motor below the base speed. That will be the first thing. So this the controlling signal that will be getting from this particular rectifier circuit. So this rectifier will be converted that the AC supply into DC supply, because this is a DC separately excited generator. So we will require some of the excitation that the particular field winding of that particular generator. So we are using some of the reversing switch here. So if you want to change the speed control of this particular strategy, that is for the above the base speed, so we have to control, that is field flux control of that particular motor. For the sake of that, now this three-phase supply again will be given to uncontrolled or controlled rectifier. So that will be again converting that the alternating current supply into direct current supply, and by the changing of this, the field winding. By the changing of this the field winding supply, we can control the speed of that particular DC motor, that is the above base speed, and due to that the load peaks are not transferred to the supply. So this is called it as what Leonard said for the system that will be preferred for the DC drives that will be used in the different types of the steel rolling mill. Now friends, we are moving towards the next type of motor, which will be called it as a synchronous motor. So first of all, we can understand why the synchronous motors are used in the different types of the steel rolling mill. So the synchronous motors are used for the driving continuous mill where load is maintained for a relatively long period for the sake of the steel rolling mill. So friends, we are using the synchronous motor for driving a continuous mill. We are preferring this type of drive. So what is the requirement for the slow speed synchronous motor can be built more economically than a induction motor, and at the same time, why we are preferring instead of the induction motor synchronous motor, because it is very economical, and by the use of the synchronous motor the power factor correction will be done, because while we are using the induction motor, so induction motor will be operated as an inductive load, and due to that the power factor of your system will be reduced. But instead of, while we are using the synchronous motor, so while we are using the synchronous motor, then obviously the power factor correction will be done. So that's why in the steel rolling mill now we are preferred the synchronous motor drive. So instead of the main mill drive, the synchronous motors are used for the various auxiliary drive. So what are the different auxiliary drive that we are using in the steel rolling mill? So the first type of the auxiliary drive or the auxiliary motors that we are using for the operation in the steel rolling mill is that driving the rolls of the roller table at a constant speed. Second, adjusting the gap between the rolls. If you want to adjust the gap between rolls, then we are preferring this type of motor. Then third, that is driving the manipulators, because the speed of that particular manipulators will be constant. So we are preferring the synchronous motor drive. After that, for the chopping, the tail ends, if you want to chop the tail ends, that's time we have to, the requirement will be the synchronous speed. So again, we are preferring the synchronous motor drive. If you want to cutting the metal to a required length, again we will require constant speed operation. So we are prefer the synchronous motor drive. And if you want to winding the ends product into the coils, again we will require at a constant speed we want to wind. So obviously we are preferring the synchronous motor drive for your steel rolling mill. Now we have to understand what are the different types of the controlling methods that we are preferring in the synchronous motor drive. So friends, as we know that synchronous motor drives are preferred in the different type of steel rolling mill, and the method that from which we can control the synchronous motor, that the method will be called it as VFD, that is called it as variable frequency drive, by which we can control the speed of your synchronous motor drive in the steel rolling mill. So what do you mean by the variable frequency? I think we have some of the fundamental concept in concern with the variable frequency drive. So in the variable frequency drive, according to our requirement, suppose friends we are having the supply voltage, that the supply voltage will be called it as the AC supply voltage will be available. Okay, so from the AC supply voltage, we are using one power modulator that will be given to your synchronous motor. So if the supply system is AC, we have to use the synchronous motor. So this is the synchronous motor. So this is the synchronous motor. Synchronous motor. Okay, so this is the synchronous motor. This is the supply system AC. We have to control the synchronous motor supply system AC, but we want to control the speed. So that's why we are using the cycloconverter for the VFD. So what is the requirement for the cycloconverter? We have to give the supply voltage, that is AC, from which we can control the supply voltage of AC. So by the changing of the firing angle of this particular cycloconverter, it will be control the speed of that particular synchronous motor. Okay, so this will be the one system. Suppose we are taking the supply system is DC. Okay, and the motor is AC. So instead of cycloconverter, we are using a device which will be convert that the DC current supply into a alternating current supply. So the supply is DC, the supply requirement for your synchronous motor is AC. Now we are preferring the inverter. So what do you mean by the cycloconverter inverter? We will call it as VFD. What do you mean by VFD? It is variable frequency drive. So what are the different requirements in the variable frequency drive? So obviously in the inverter circuit we are using VFD. So we are giving the V and F reference signal to that particular block. So what do you mean by the V and F reference signal to that particular block? So if we have the fundamental concept in the construction of V by F control scheme. So if you want to maintain a flux constant in that particular the synchronous motor, we have to maintain that particular ratio of variable voltage according to your frequency. So we have to maintain this ratio constant, that is V by F ratio constant. So if you want to control the speed of your motor by the maintaining the voltage keeping constant and by the changing of the frequency, you have to get the speed control of this synchronous motor. So this is the actual concept of the VFD. So I think friends, we have discussed earlier the detailed working of the VFD. So we can refer this the detailed working of VFD for the sake of your synchronous motor drive. Now friends, we are moving towards the next type of motor which will be very popular nowadays in a different type of the steel rolling mill, because due to its different types of the properties. So nowadays friends, obviously the steel rolling process which will require a repeated and rapid bidirectional hot rolling operations uses BLDC motor drive, because instead of the slip ring induction motor, instead of the DC motor, most of the time the BLDC motor will possesses very good characteristics. The size of this motor as compared with the DC motor and the slip ring induction motor, the size of this motor will be less. The various properties that will be very better. So what are the different advantages in the rolling mill operation we can understand by the use of the BLDC drive. So the first advantage of that particular system is that it will be produce a high torque to current ratio, because we have the requirement that is torque should be high, current should be high, and second requirement that is high power to weight ratio. So friends, in the rolling mill we will require this very important parameter, and the BLDC motor will give these all two parameters. So obviously we are preferring BLDC drive. Then the third, that will be the quick response to load fluctuations and the speed reversal. So obviously in concern with the steel rolling mill, we have to use a reversible steel rolling mill. So instead of the DC motor, instead of the induction motor, we are preferring nowadays that is BLDC motor. So the next advantage will be can operate over a wide range of speed efficiently, because obviously the DC motor will be again give you wide range speed, but along with the BLDC motor which will be having the construction that is brushless. So due to that the maintenance of that particular drive will be very less, and due to that efficiency and the life of this particular drive will be large. So instead of the DC motor, nowadays we are preferring the BLDC drive for the steel rolling mill. And along with that, while delivering a nearly full load rated torque and are amendable to precise control using feedback signal, because for the sake of the BLDC drive, so the BLDC drive will give you obviously a precise speed control technique along with its feedback control signal. So that's why nowadays in the industry of the steel rolling mill we are preferred the BLDC drive. So now friends, we can understand where we can use this BLDC motor drive. So to the identical BLDC motor drive system coupled to the steel rolling mills through the reduction gear. So this is the actual diagram by which we can use the two BLDC motor. So friends, these are the power circuit of BLDC motor and its controller. So this is the BLDC drive actually. So this BLDC drive is coupled basically to a reduction gear system. So this is the actual the mechanism, and this is the reduction gear system by which we can connect this BLDC motor to different two types of the hot rolling mill. So that particular this workpiece will be converted into the small thin sheets. So this is the direction of rotation, that will be called it as backup roll. This is the backup roll. So this is the direction of rotation of this roll, will be reversible drive. So this is the spindle, this is the work roll. So obviously, what is the purpose of that particular BLDC motor? So these BLDC motors are connected to that particular gear mechanism. So by the changing of the speed of this particular BLDC motor, so it will give you, that is high torque to current ratio, that is high power to weight ratio. So depending upon that, the various advantages. So by the use of this BLDC motor, we can give the precise control of this particular block at a particular shape. So that's why these BLDC motor are preferred in the various types of the hot rolling steel mills. So this is the actual system. Now we can understand the block diagram of the BLDC drive. So this is the block diagram of the BLDC drive, in which we are using the intelligent power module. So what do we mean by that is an intelligent power module? We call it as the different types of rectifiers and inverter circuit, that will be call it as intelligent power module. So by which we can control the signals of the BLDC motor. So friends, first of all, we can understand what will be the working. So we are giving the three-phase supply to that particular first block, that will be using in the BLDC drive system. So this is a diode bridge rectifier. So what is the purpose of this diode bridge rectifier? This diode bridge rectifier will convert the alternating current supply into a direct current supply to according to your requirement. Now this DC supply will be given to your inverter circuit. So as we seen that friends, in between this diode bridge rectifier and the inverter, we are using the different types of filter circuit by which we can get a purely DC supply to that particular inverter. So as we know that the alternating current supply will be converted to the direct current supply by the use of this rectifier. Now this pure DC supply will be converted to your BLDC motor, because this BLDC motor are also called as permanent magnet BLDC motor. So in that the construction of the permanent magnet BLDC motor, the armature is made up of, or the stator will be similarly to the type of the armature winding, and the rotor will be basically made up of with the different types of the permanent magnet. So that the BLDC motor will be called it as permanent magnet BLDC motor, and we will require the AC supply or the different types of the armature winding. The supply required for the BLDC motor is the AC. So that the AC supply will be converted, that is from DC supply to AC supply. This is by the three-phase 6 pulse inverter. So in that particular inverter circuit, we are using different types of techniques, such will be called it as pulse width modulation inverter control technique. So this three-phase 6 pulse inverter will convert that the direct current supply into the alternating current supply. Now this alternating current supply will be given to the armature winding or the stator winding of your BLDC motor. So according to the changing in the direction of that the stator winding of your BLDC motor, rotor will be the rotate. So friends, according to that, the BLDC motor will changes its speed. Now this BLDC motor will be used in a rolling mill for a particular hot roll type of material, which will be give you a high torque to current ratio. So friends, for the sake of that, we are using one type of sensor, which will be called it as the speed sensor. So by which we can give you speed sensor technology. So this is the actual speed which will be sensed by this speed sensing unit. Now this speed sensing unit will give you the signal to your control technique. So friends, as shown in figure, in that particular system, we are using one type of the controller. That type of the controller will be called it as the ARM Cortex development board type of controller. So this controller will be coupled to the PC or the keyboard. Similarly, instead of this controller, we are using nowadays, that is PLC controller, that is programmable logic controller. So these all operations are done in that the PLC itself, because in that the PLC we are doing the programming, that is the programming by means of the different types of the PCs and keyboards. So from that particular, we have to generate the different types of the control signal to that particular BLDC motor, and by the use of this whole PLC signal or the by this whole PLC controller, we will control the speed of this particular BLDC motor drive. So friends, this is the actual working of the BLDC motor drive that we are preferring for your steel rolling mill. I think everyone has got the clear understanding and concept that the various drives that we are preferred for the steel rolling mill. Thank you.